Okay, so welcome everyone to the class. Today the topic that we are going to discuss is law of radioactive decay. First, let us see what is law of radioactive decay. It says that the number of nuclei undergoing decay per unit time. It says that what number of nuclei undergoing decay per unit time is proportional to number of nuclei present at that time. So this is the basic statement of law of radioactive decay. Number of nuclei undergoing decay per unit time is proportional to number of nuclei present at that time. What does this statement mean and how we will go for the derivation? Let's have a look. Suppose delta n number of nuclei undergoes decay. That means we count delta n number of nuclei undergoes decay in delta t time, and at that time let n be the number of nuclei present in the sample. Okay, let's see once again what I am telling. Suppose delta n is the number of nuclei undergoing decay in time delta t, and n is the number of nuclei present at that time in the given sample. Then from the law of radioactive decay, we can write this. Delta n by delta t is proportional to n. The number of nuclei undergoing decay per unit time is proportional to the number of nuclei present at that time. So delta n by delta t is proportional to n. Suppose if delta t tends to 0, that means limit delta t tends to 0, then delta will change into d. So dn by dt should be proportional to n. And the constant of proportionality in this expression is called lambda. What is lambda? Lambda is called decay constant. Lambda is called decay constant. It is a positive quantity. So it should remain positive everywhere. Minus sign has been implemented here. Why minus sign? Because this is delta n. Nuclei is undergoing decay. Decay means the final number of nuclei will be always less than initial number. So to make it always positive, we add a negative sign here. Understood? So lambda is called decay constant. Now we can do the derivation. Have a look. Dn by n is equals to minus lambda dt. From this expression itself, dn by dt is equals to minus lambda n. So dn by n is equals to minus lambda dt. Suppose I am putting the limits. Initially the number of nuclei was n0. That means at time t equals to 0, the number of nuclei in the sample was n0 initially, and at time t it becomes n. Obviously n is less than n0. Again, see how I am putting the limits. At time t equals to 0, initial number of nuclei was n0. At time t, the final number of nuclei is n. N is obviously smaller than n0. So if we do the integration, what is the integration of dn by n? Log n. n0 n minus lambda, and integration of dt will be t 0 to t. So we can write upper limit minus lower limit should be equals to minus lambda t. Log b minus log a, if you remember the property of the log b minus log a is log b upon a is equals to minus lambda t. Log b minus log a is equals to log b upon a is equals to minus lambda t. Another property of the log, if log is taken to the another side, it becomes exponential function. So n by n naught is equals to e to the power minus lambda t. So n is equals to n naught e to the power minus lambda t. This is the required expression for law of radioactive decay. N equals to n naught e to the power minus lambda t. Go through it once more. This was the expression initially at time t equals to 0, n is equals to n naught. Means initial number of nuclei is n naught, at t equals to t the number of nuclei is n. Then we have done the calculus. Integration of dn by n is log n. Lower limit, upper limit. Integration of dt is t. Again, upper limit minus lower limit is equals to minus lambda t. Then we have used the property of log. Log b minus log a is equals to log b upon a. That is log n upon n naught is equals to minus lambda t. Then n upon n naught, if you put the log on the other side, it will become the exponential function. This property, if you remember, if log x is equals to y, that means x is equals to e to the power y. This is the property that we have used here from this step to this step. And by n naught is equals to e to the power minus lambda t. So n is equals to n naught e to the power minus lambda t. So this is the required expression for law of radioactive decay.